Okay, so now we are going to verify that these two are inverse functions using function composition. And remember here from our steps, it does remind us that we need to show that f of f inverse of x is equal to x, and that f inverse of f of x is equal to x. So let's start first with finding that f of f inverse of x is equal, hopefully, to x. So let's start, let's actually do that now. And I'm going to take this f inverse function, x squared plus 3 over 2, and I'm going to substitute that in for the x of this f of x. Let me move this down just a smidge. Okay, so starting with this f of x function, I have the square root of 2 times, and now I'm going to open up my parentheses and input f inverse of x here, x squared plus 3 over 2. And then finishing out this function f of x, I'm going to subtract the 3. So now let's continue with our simplifying. It looks like here inside the radical, we have this multiplication by 2 and then a division by 2 here. So those can actually cancel out. And we are just left with the square root of, let's see, x squared plus 3. And then we still have that minus 3 on the outside. You can put parentheses around this x squared plus 3, but I guess it doesn't really matter when there's not a multiplier on the outside. So now, again, inside the radical, we have a positive 3 and a negative 3, which just equals 0 when combined. So we have the square root of x squared. And again, we know those to be inverse operations. So the square root of x squared is simply x. So we've got this checked off, that f of f inverse of x equals x. Now, for the second part, we want to show that f inverse of f of x is also x. So kind of going the opposite direction. Okay. We're going to take this function, f of x, the square root of 2x minus 3, and we're going to input it in for this x here in f inverse. So actually, this function starts with x. So we're going to start with the square root of 2x minus 3. Because that's our f of x, that's our input. But now, continuing with f inverse of x, we're going to square that, add 3, and then divide by 2. So we're going to square this, then we're going to add 3, and then we're going to divide the whole thing by 2. So again, we've input f of x into f inverse. So continuing with our simplification here, let's see, we have the radical, the square root, and square. So those are inverse operations. That just gets rid of the radical, giving us 2x minus 3, and then we have that plus 3 on top, still dividing by 2. So now, again, on the numerator, we have a negative 3 and a positive 3, which just equals 0 when combined. So we have a 2x divided by 2. And then now, of course, the 2 divided by 2 is just 1, which is just giving us 1x, or regular old x. So now we have verified that these two functions are inverses because both f of f inverse of x equals x, and f inverse of f of x equals x.